Alright class, in this video I'll be doing the first of two examples from section 14.3. A fence must be built to enclose a rectangular area of 5,000 square feet. Fencing costs $4 per foot for the two sides facing north and south, and $8 per foot for the sides facing east and west. Find the cost of the least expensive fence. So the objective is to minimize cost. So we're going to create a cost function. And so over here on the left, I've already drawn the rectangle. We're going to label this side X, this side Y. And to build the cost function, we're going to go back to the problem, and it says the fencing costs $4 per foot for the two sides facing north and south. So the cost for the south facing fence will be $4 per foot, and the fencing facing north will be $4 per foot. The problem states that fencing costs $8 per square foot for the fencing facing east and west. So over here, we're going to write 8y for the total cost for the sides of the fence facing east-west. And if we combine like terms, the cost function is 8x plus 16y. Okay, now this function has two variables in it. It has an x and a y, and we would like to write a cost function that has just an x in it. So now we're going to take what we call the constraint and use that to replace this y. So the constraint in this problem is the fact that there's only 5,000 square feet of fencing. So the area of that rectangle is equal to x times y, which means 5,000 is equal to x times y. So y is equal to 5,000 divided by x. Now that we have all the information that we need, we can write the cost function in terms of x, and that's going to be 8x plus 16 times the 5,000 divided by x. And if we clean that up, the cost function is 8x plus 80,000 x to the negative 1 power. Okay, now that we have a cost function, again, remember that our objective is to minimize the cost. So to find the value of x that minimizes the cost function, we're going to take the derivative. And the derivative of this function is 8 minus 80,000 x to the negative 2, and we're going to set that equal to 0. Now, if this wasn't a word problem, you'd be required to solve that for x by hand. However, this is a word problem, so you have access to Desmus. So what we're going to do is we're going to use Desmus to graph the original cost function, c of x. And when you do that, you'll find that the minimum value of c of x is 1600, when x is equal to 100. So the cost of the least expensive fence is $1,600.